As you gently drift into a realm of cosmic exploration, imagine yourself as a quiet observer floating amidst the stars. Welcome to Bedtime Astronaut, where we embark on serene journeys through the wonders of our universe. Tonight, we turn our gaze to the edges of our cosmic neighborhood, pondering the profound question: where does the solar system end? To grasp this concept, we first delve into what we mean by the solar system. Our solar system is a vast, fascinating expanse centered around the radiant warmth of our sun. It is a family of celestial bodies, all bound together by the sun's immense gravitational embrace. The solar system includes 8 major planets, each with its own unique characteristics and entourage of moons. From the rocky, sun-bathed surfaces of Mercury and Venus to the vibrant blues and greens of Earth, and beyond to the crimson deserts of Mars. Further still, we encounter the gas giants, Jupiter and Saturn, with their swirling storms and intricate ring systems. And then, the icy realms of Uranus and Neptune, where the sun appears as little more than a distant star. As we continue our journey outward, we pass through the realm of the dwarf planets, such as the enigmatic Pluto, nestled in the Kuiper Belt. This region is a vast, toroidal expanse of icy objects and remnants from the solar system's formation. It is a place where time seems to slow, a contemplative space where one can ponder the origins of our celestial home. However, to define the solar system's boundaries, we must venture even further, past the familiar paths of the planets and into the deep, dark stretches of interstellar space. Here, we encounter the heliosphere, a vast bubble inflated by the solar wind, a continuous stream of charged particles emanating from the sun. The heliosphere acts as a protective cocoon, shielding the solar system from the majority of cosmic rays and interstellar material. The edge of this bubble is known as the heliopause, a boundary where the solar wind slows down and merges with the interstellar medium. It is often considered the outermost boundary of our solar system. Beyond the heliopause lies the interstellar space, a region filled with material from other stars and the remnants of stellar processes. Yet the solar system's influence extends even beyond this boundary. The Oort Cloud, a hypothetical, distant shell of icy objects, is believed to encircle the solar system at its farthest reaches. It is thought to be the source of long-period comets that occasionally grace our skies. This vast, spherical cloud is situated so far from the sun that its gravitational influence is weak, and the objects within it are easily perturbed by the gravitational pull of passing stars. The Oort Cloud is a reminder of the solar system's dynamic nature, a place where the sun's influence gradually wanes and interstellar space begins. It is a region that has yet to be directly observed, residing at such great distances that it challenges the limits of our current technological reach. Yet, its existence is supported by mathematical models and the behavior of comets that return from these distant realms. As we contemplate the edges of the solar system, we are reminded that boundaries in space are not as clear-cut as those we encounter on Earth. In the vastness of the cosmos, transitions are often gradual, a blending of influences rather than abrupt changes. The solar system, with its intricate dance of celestial bodies, serves as a microcosm of the universe itself, a place of continuous discovery and wonder. In this gentle exploration, you might find yourself pondering the nature of boundaries, both in space and in our understanding. The solar system's end is not a definitive line, but a region where our sun's influence gives way to the greater galaxy beyond. It invites us to consider the interconnectedness of all cosmic phenomena and our place within this vast tapestry. As we float peacefully in this cosmic expanse, we are reminded of the endless avenues of exploration that lie before us. The solar system, with its myriad wonders, is but one chapter in the grand story of the universe. By contemplating its boundaries, we gain a deeper appreciation for the intricate balance that governs the celestial dance of planets, stars, and galaxies. And so, as we gently drift through this cosmic ocean, let us carry with us a sense of wonder and curiosity, embracing the mysteries that lie just beyond the horizon of our understanding. Each star, each planet, each distant comet holds a story waiting to be discovered, whispering secrets of the universe to those willing to listen. In this serene moment, let the stars be your guide, and the universe your gentle companion, as you embark on your own journey of exploration and contemplation. As we continue our tranquil journey beyond the known confines of our solar system, we find ourselves on the threshold of the interstellar medium, a vast and enigmatic region that stretches between the stars. This realm is composed of gas, dust, and cosmic rays, a delicate and sparse mixture that whispers of the processes that have shaped galaxies over eons. Within this vast expanse, the material is so thinly spread that it resembles a fine mist, yet it plays a crucial role in the life cycle of stars and the formation of new celestial bodies. Here, the interstellar medium serves as a bridge between the remnants of ancient stars and the birthplaces of new ones, a seamless continuum that connects the past, present, and future of the cosmos. As we glide further into this realm, we can sense the subtle interplay of cosmic forces at work. The interstellar medium is not a static void but a dynamic environment, influenced by the shockwaves of supernovae, the gentle push of stellar winds, and the magnetic fields that thread through the galaxy. These forces help to sculpt the structure of the medium, creating vast bubbles and filaments that can stretch across light years. It is within these structures that new stars may eventually form, as gravity pulls the material together, kindling the nuclear fusion reactions that ignite new suns. Even as we marvel at the vastness of interstellar space, we remain anchored by the knowledge that our own solar system is just one of countless others scattered throughout our galaxy. The Milky Way, our cosmic home, is a sprawling spiral galaxy composed of hundreds of billions of stars, each potentially harboring its own array of planets, moons, and other celestial bodies. This immense collection of stars is organized into a graceful spiral structure, with arms that curl outward from a dense central bulge. These arms are rich with the raw materials of star formation, glowing with the light of young stars and the diffuse luminescence of nebulae. As we continue to sail through this celestial ocean, we might pause to consider the journey of our own sun and its family of planets as they orbit the center of the Milky Way. Our solar system completes one full orbit approximately every 230 million years, a gentle and stately dance that has been ongoing since the sun first ignited over 4 billion years ago. This journey through the galaxy is not a solitary one. Instead, we are accompanied by countless other stars and systems, each on its own unique path through the cosmos. The vastness of interstellar space also invites us to reflect on the potential for life beyond our own planet. The search for extraterrestrial life is a quest that stretches the imagination and challenges our understanding of biology and chemistry. Scientists seek clues in the atmospheres of distant exoplanets, looking for the signatures of water vapor, oxygen, and other indicators that might suggest the presence of life. The discovery of even the simplest forms of life beyond Earth would have profound implications, reshaping our understanding of our place in the universe and the potential for life to arise elsewhere. As we drift through this boundless region, we might consider the cosmic distances that separate us from these distant worlds. Light, traveling at its incomprehensible speed, takes years, centuries, or even millennia to traverse the vast spaces between the stars. This vastness means that communication with any potential extraterrestrial civilizations would require patience and perseverance, as messages would take years to reach their destinations, and any replies would be equally delayed. Despite these challenges, the search for life beyond Earth continues to inspire and captivate, driven by the hope that we might one day find a connection with other forms of life in the universe. Gently, our thoughts might turn to the grand scale of the universe itself, a cosmos that stretches beyond the limits of our imagination. The observable universe, the portion that we can see and study, is estimated to be about 93 billion light-years in diameter. Within this vast expanse are billions of galaxies, each a swirling collection of stars, planets, and other celestial objects. The sheer magnitude of the universe invites us to ponder the possibilities it holds, from the nature of dark matter and dark energy to the ultimate fate of the cosmos itself. Dark matter, an elusive and mysterious substance, makes up a significant portion of the universe's mass, yet it remains undetected by conventional means. It does not emit, absorb, or reflect light, but its presence is inferred through its gravitational effects on visible matter. Galaxies rotate at speeds that suggest they are embedded in massive halos of dark matter, and the large-scale structure of the universe is shaped by its gravitational influence. While the nature of dark matter remains one of the greatest mysteries in astrophysics, its existence is a reminder of how much we have yet to learn about the universe. Equally enigmatic is dark energy, a force that appears to be driving the accelerated expansion of the universe. This mysterious energy is thought to permeate all of space, exerting a repulsive force that counters the gravitational pull of matter. While much about dark energy is still unknown, its discovery has profound implications for our understanding of the cosmos and its ultimate destiny. Some cosmologists suggest that this expansion may continue indefinitely, leading to a cold, dark, and dispersed universe in the distant future. As we gently contemplate these cosmic mysteries, we might find solace in the knowledge that our journey through the universe is one of continual discovery. Each new observation, each new piece of data, adds to our understanding of the cosmos and our place within it. The universe, with its infinite complexity and beauty, beckons us to explore, to learn, and to seek answers to the questions that have captivated humanity for millennia. This serene exploration, we are reminded of the interconnectedness of all things. From the smallest particles to the largest galaxies, the universe is a tapestry of relationships and interactions. Every atom in our bodies was forged in the heart of a star, and every star is part of the grand cosmic dance that unfolds across the universe. This interconnectedness invites us to reflect on the bonds we share with each other and with the cosmos itself, fostering a sense of unity and belonging. As we conclude this portion of our journey, we carry with us a sense of awe and wonder, inspired by the vastness and beauty of the universe. The cosmos, with its endless mysteries and possibilities, calls to us, inviting us to continue our exploration and to embrace the profound questions that lie at the heart of our existence. We are travelers in a universe that is both ancient and ever new, a universe that beckons us to look beyond the horizon and to dream of the worlds that await. As we continue our serene voyage through the cosmos, we find ourselves contemplating the boundaries of our solar system, a fascinating topic that invites us to explore the vastness beyond the familiar planets that orbit our sun. The concept of where the solar system ends is not as straightforward as it might seem at first glance. Unlike a distinct, visible line or a physical barrier, the edge of our solar system is defined by invisible forces and gradual transitions. It begins with the heliosphere, a vast bubble of charged particles emitted by the sun, known as the solar wind. This solar wind extends far beyond the orbits of the outer planets, creating a protective shield that separates our solar system from the interstellar medium. Within this boundary, the solar wind flows outward until it encounters the interstellar medium, where its strength diminishes. This region is known as the heliopause, often considered the outermost boundary of the solar system. It is here that the solar wind slows and eventually merges with the material of the interstellar medium. Beyond the heliopause lies the interstellar space, a realm that invites us to imagine the countless stars and planets that exist beyond our immediate celestial neighborhood. As we glide gently past the heliopause, we enter the Oort Cloud, a theoretical cloud of icy bodies that surrounds our solar system. This distant region is believed to be the source of long-period comets, those celestial travelers that occasionally visit the inner solar system, offering us a glimpse into the primordial materials from which the solar system formed. The Oort Cloud represents a boundary that is not fixed, but rather a vast, diffuse sphere that stretches perhaps 1,000 times farther from the Sun than the Earth. The objects within the Oort Cloud are thought to be remnants of the early solar system, frozen in time and space, providing a quiet testament to the origins of our planetary neighborhood. Imagining ourselves drifting through this ethereal realm, we can ponder the immense distances involved. The Voyager spacecraft, those intrepid explorers launched in the late 20th century, have traveled for decades to reach the heliopause. Even these remarkable machines, voyaging through the darkness, have only begun to touch the fringes of the Oort Cloud. This highlights the sheer scale of our solar system and the challenges inherent in reaching such distant locales. As we contemplate these outer reaches, we are reminded of the intricate dance between gravitational forces that govern the movements of celestial bodies. The Sun's gravity holds sway over the planets and the far-off objects within the Oort Cloud, yet even its influence wanes with distance. Beyond the solar system's outer edges, the gravitational forces of other stars begin to exert their influence, hinting at the interconnectedness of our galaxy. The journey to define the outer limits of our solar system also brings us to consider the remarkable persistence of human curiosity. The desire to explore and understand these distant frontiers is driven by a quest to comprehend our place within the vastness of the universe. The boundary of the solar system is not merely a physical demarcation, but a frontier of knowledge, where each new discovery enriches our understanding of the cosmos. Reflecting on this, we find comfort in the idea that even as we push the boundaries of exploration, there remains so much more to discover. The solar system's edge is not an end but a beginning, an invitation to look beyond and wonder at the mysteries that lie in the interstellar realm. This journey prompts us to consider the possibility of other solar systems, each with its own unique characteristics, and perhaps harboring life in forms we have yet to imagine. In the silence of space, we are reminded of the beauty of these distant domains. The stars that adorn our night sky are but a fraction of the billions that make up the Milky Way galaxy. Each star is a sun, potentially hosting its own family of planets, moons, and other celestial phenomena. The search for exoplanets, planets beyond our solar system, continues to reveal a diverse array of worlds, some of which may reside in the habitable zones of their parent stars, where conditions might be right for life as we know it. As we float gently through our thoughts, we might also consider the cosmic forces that influence the structure and evolution of galaxies. Dark matter, that elusive substance, is one such force. Though invisible, its gravitational effects shape galaxies, including our own, guiding the motion of stars and contributing to the formation of cosmic structures. This enigmatic matter, along with dark energy, which drives the accelerated expansion of the universe, remains a profound mystery that captures the imagination of scientists and dreamers alike. While pondering the vastness and complexity of the universe, we naturally return to the comforting familiarity of our own solar system. The planets and moons that orbit the Sun are each a world unto themselves, with unique geologies, atmospheres, and potential for harboring life. The exploration of our neighboring planets, such as Mars with its ancient riverbeds, or Europa, with its icy crust concealing a subsurface ocean, continues to inspire awe and wonder. In contemplating the boundaries of the solar system, we also reflect on the delicate balance of conditions that make Earth a haven for life. Our planet's position in the solar system allows for liquid water, a stable climate, and the rich diversity of life that we cherish. This balance serves as a reminder of the fragile beauty of our home and the interconnectedness of life across the cosmos. As we draw this gentle exploration to a close, we are left with a sense of profound peace, knowing that the universe is vast and filled with wonder. The boundaries of our solar system, elusive and ever-expanding, serve as a metaphor for the limitless potential of discovery and the eternal quest to understand our place in the cosmos. With each new revelation, we are reminded of the beauty and mystery that lies beyond, inviting us to continue our journey with curiosity and an open heart. As we extend our gaze beyond the heliopause, the frontier where solar winds surrender to the vastness of interstellar space, we find ourselves contemplating the sheer enormity of the cosmos. It is here, beyond the reach of our sun's immediate influence, where the interstellar medium begins to weave its delicate tapestry. This region is not empty, but rather filled with a sparse mixture of gas, dust, and cosmic rays, remnants of ancient stars and the seeds for new ones. The interstellar medium cradles our solar system, a gentle reminder of the cyclical nature of the universe, where the death of stars gives birth to new celestial bodies, sowing the seeds of continuity in the starry expanse. Far beyond the comforting warmth of our sun, the Oort Cloud is hypothesized to stretch out like a vast, spherical shell, its icy bodies lingering in a distant dance. While the inner solar system is a realm of rocky planets and gaseous giants, the Oort Cloud is a place of icy solitude, where comets bide their time in the cold, waiting to be nudged by the gravitational whispers of passing stars or the subtle tugs from our galaxy, the Milky Way. These distant wanderers, on their long journeys toward the inner solar system, offer a glimpse into the primordial past, carrying with them the ancient materials that once swirled around a young sun. As we consider the boundaries of our solar system, it becomes evident that these limits are not rigid lines, but rather transitional zones, much like the twilight that bridges day and night. The heliosphere, the heliopause, and the Oort Cloud form these gentle gradients, guiding us from the familiar embrace of our solar neighborhood into the broader canvas of the galaxy. They invite us to consider not only the vastness of space, but also the subtle forces that shape it, from the gravitational pull of our sun to the magnetic fields that ripple through the interstellar medium. In this cosmic tapestry, where does the influence of our solar system truly end? Some might say it is where the gravitational pull of the sun fades into insignificance, while others might point to the heliopause as the defining boundary. Yet, as we explore these concepts, we realize that our solar system is but one thread in the intricate weave of the Milky Way, a galaxy filled with its own wonders and mysteries. It is within this larger context that we find the sun's journey through space, as it orbits the galactic center, taking our entire solar system along for the ride. The solar system's path through the galaxy is not a solitary one. It is part of a grand celestial dance, a spiral arm of the Milky Way that cradles countless stars, each with its own systems and stories. As our sun orbits the galactic center, completing a journey every 225 to 250 million years, it traverses regions of varying density and energy. This cosmic migration influences the heliosphere, compressing or expanding it as our solar system passes through interstellar clouds and regions of differing interstellar medium characteristics. This journey through the galaxy is a reminder of the interconnectedness of all things. The sun and its family of planets are part of a dynamic and ever-changing universe, influenced by forces both near and far. The gravitational interactions with nearby stars, the influence of the galactic spiral arms, and the subtle currents of the interstellar medium all contribute to the grand narrative of cosmic evolution. As we contemplate the boundaries of our solar system, we cannot help but reflect on the broader universe and our place within it. The cosmic web stretches beyond our imagination, a vast network of galaxies, stars, and planets, each with its own story to tell. In this immense universe, our solar system is but a tiny speck, a fragile oasis in the grand expanse of space and time. Yet it is this very fragility that fuels our curiosity and our desire to explore. The quest to understand where the solar system ends is part of a larger journey to comprehend the universe itself, its origins, its structure, and its destiny. As we send probes like Voyager and New Horizons into the unknown, we reach out with a sense of wonder, seeking answers to questions that have long fascinated humankind. In this exploration, we are reminded of the beauty and complexity of the universe, a universe that is at once familiar and mysterious. The boundaries we seek to define are but stepping stones on a path of discovery, guiding us toward a deeper understanding of the cosmos and our place within it. As we continue to explore the universe, we find that the boundaries of our solar system, like the horizon, are not fixed. They shift and change with our growing knowledge, revealing new wonders and challenges that inspire us to look beyond the immediate and to embrace the grand adventure of cosmic discovery. Our journey through space and time is ongoing, a testament to the enduring spirit of exploration and the human quest to know, to understand, and to marvel at the beauty of the universe. In contemplating these cosmic boundaries, we are gently reminded of Earth's unique position as a cradle of life. The conditions that allow life to flourish on our planet are finely balanced, a delicate interplay of factors that have converged to create an environment where life can not only exist but thrive. As we gaze outwards, it becomes apparent that our solar system, with its diverse landscapes and celestial bodies, holds insights into the processes that give rise to life, offering clues about the potential for life beyond our own world. In the quiet of this reflection, we recognize the interconnectedness of all things, from the smallest particles to the largest galaxies. The universe is a continuum, where each part contributes to the whole, and our solar system is a unique chapter in this grand narrative. It invites us to reflect on our role as stewards of our planet, reminding us of the responsibility to cherish and protect the world we call home. This gentle contemplation leads us to a deeper appreciation of the universe's complexity and the elegance of its design. It is a reminder that while we have come far in our understanding, there is still much to learn, much to explore, and much to discover. The universe invites us to look up with a sense of wonder, to ponder the mysteries that lie beyond, and to embrace the journey of discovery that awaits us. As we draw our exploration of solar system boundaries to a close, we find ourselves back where we began, reflecting on the beauty and wonder of the cosmos. The questions we ask and the answers we seek are part of an endless cycle of curiosity and discovery, a testament to the human spirit's resilience and determination to explore the unknown. The universe, vast and infinite, invites us to continue this journey, to look beyond the horizon, and to embrace the adventure of understanding the cosmos and our place within it. In these moments of serene reflection, we find peace in knowing that we are part of something much larger than ourselves, a universe that is both ancient and ever-changing, filled with possibilities and secrets waiting to be uncovered. The journey continues, and with it, the promise of new discoveries, new insights, and a deeper connection to the cosmos. The universe, in all its grandeur, invites us to be curious, to explore, and to marvel at the beauty of creation as we continue our gentle voyage through space and time. As we continue our journey beyond the familiar embrace of our solar system, we venture into the profound silence of interstellar space, where the vastness can be felt not just in distance, but in the timelessness of the cosmos. Here, the concept of boundaries becomes ethereal, for in truth, space is an endless sea, with divisions that are more conceptual than physical. Beyond the heliopause lies the interstellar medium, a sparse and delicate dance of gas and dust, remnants of ancient stars whose life cycles have contributed to the tapestry of the galaxy. This medium, while seemingly empty, is far from void. It holds the potential for new stars, new systems, and new stories. It is a reminder of the interconnectedness of all things, a cosmic web that binds the past to the present and future. As we contemplate the vastness of this space, it's worth considering the role of gravity, that unseen force that shapes the orbits of planets, holds galaxies together, and influences the path of light itself. Gravity, though gentle, is relentless, and it governs the motion of celestial bodies with a precision that humbles our understanding. In this grand ballet, stars and their planets move not in isolation, but as part of a larger, harmonious choreography. The gravitational pull of the Milky Way's spiral arms can gently nudge comets from the Oort Cloud, sending them on long journeys toward the sun, where they become momentary visitors to the inner solar system, carrying with them tailies from the farthest reaches of our cosmic neighborhood. As we drift further into this thought, one might imagine the faint whisper of cosmic rays, high-energy particles that travel across vast distances, traversing galaxies and interstellar spaces. These particles, born of supernovae and other cataclysmic events, carry with them the energy and essence of their origins, weaving a subtle connection between the stars and the spaces between them. They are the silent messengers of the universe, reminding us of the dynamic processes that continue to shape the cosmos even in its quietest corners. Our understanding of where the solar system ends is further enriched by the Voyager spacecraft, those intrepid explorers launched decades ago, now journeying through the boundaries of our solar neighborhood. These spacecraft, having crossed the heliopause, continue to send back whispers from the edge, providing invaluable data about the conditions of interstellar space. Their mission is a testament to human curiosity and ingenuity, a desire to reach out and touch the stars, to extend our senses beyond the confines of Earth. Each bit of data collected reveals a universe in constant motion, a place where the solar wind meets the interstellar wind, creating a complex region of interaction that we are only beginning to understand. Beyond the immediate influence of the sun, the scale of the universe expands exponentially. We move from considering our solar system to contemplating our place within the Milky Way galaxy. The Milky Way, a barred spiral galaxy, is a grand structure composed of billions of stars, each with its own potential for planets and perhaps life. As we orbit the galactic center, we are part of a grand spiral arm, a feature that is common in spiral galaxies yet unique in its particular arrangement and composition. This spiral structure is not static. It slowly rotates, driven by the gravitational pull of the galaxy's mass, which includes not just visible stars, but also the enigmatic dark matter, a mysterious substance that makes up a significant portion of the universe's mass. Dark matter, invisible and elusive, is inferred by its gravitational effects, shaping the formation and evolution of galaxies. As we ponder these vast distances and the forces at play, it is calming to reflect on the light that travels through space, light from distant stars, some of which has journeyed for millions of years to reach us. This light, traveling at the universal speed limit, provides glimpses into the past, allowing us to see stars as they were long ago. It is a bridge across time, a constant reminder of the enduring nature of the cosmos. The photons that reach our eyes or our telescopes carry with them stories of birth, life, and death, stories written in the language of light, waiting to be deciphered by those who seek to understand. With each passing moment, the universe continues its expansion, a process that began with the Big Bang and continues to this day. This expansion is not just a movement of galaxies away from one another, but a stretching of space itself, a concept that challenges the boundaries of human perception. As space expands, distances between galaxies increase, and the light from the most distant galaxies shifts toward the red end of the spectrum, a phenomenon known as redshift. This cosmic expansion is a fundamental aspect of our universe, a testament to the dynamic nature of existence on the grandest scale. In contemplating where the solar system ends, we are invited to consider not just the physical boundaries, but also the philosophical implications of such a question. The universe, in its vastness, offers an endless canvas for exploration and discovery. It challenges us to expand our horizons, to look beyond the immediate and the known, and to embrace the unknown with a sense of wonder and humility. It is a journey that is as much about understanding ourselves as it is about understanding the cosmos. As we conclude this reflection, let us carry with us the notion that we are part of something much greater than ourselves. The universe, with its intricate patterns and boundless mysteries, is a vast ocean of potential, waiting to be explored. Each star, each planet, each distant galaxy is a testament to the beauty and complexity of creation. And while the solar system may have a boundary defined by the reach of the sun's influence, the spirit of exploration has no such limits. It is boundless, driven by the innate human desire to discover, to learn, and to connect with the universe that is our home. In this grand cosmic symphony, we are both observers and participants, forever linked to the stars and the spaces between them. As we continue our exploration of where the solar system truly ends, we find ourselves pondering the nature and boundaries of our cosmic neighborhood. The concept of the end of the solar system is not defined by a physical boundary, but rather by a gradual transition from the influence of our sun to the realm of interstellar space. This transition occurs at the heliopause, a fascinating region where the solar wind, a stream of charged particles emanating from the sun, slows down and eventually merges with the interstellar medium. Here, the solar wind's pressure balances with the pressure of the interstellar medium, creating a kind of cosmic shoreline. The heliopause is a dynamic, fluctuating boundary, constantly shifting with the solar cycle and interstellar conditions. Beyond this threshold lies the heliosheath, a turbulent area where the solar wind slows abruptly, creating a shockwave as it collides with the incoming interstellar medium. It is in these outer reaches that the Voyager spacecraft have ventured, giving us invaluable insights into the characteristics of this distant frontier. As we contemplate these outer boundaries, it is essential to consider the role of the sun's gravity, which extends far beyond the heliopause. The gravitational influence of the sun defines the Oort Cloud, a theoretical shell of icy bodies that envelops our solar system at great distances. This vast reservoir of comet-like objects, thought to be remnants from the solar system's formation, extends nearly a quarter of the way to the nearest star, hinting at the profound reach of our sun's gravitational embrace. The Oort Cloud is a region largely unexplored, yet its existence is inferred from the orbits of long-period comets that occasionally grace our skies with their luminous tails. These comets, thought to be nudged from their distant orbits by passing stars or the galactic tide, bring with them whispers of the solar system's ancient past. In this grand cosmic scale, our solar system is but a small part of the Milky Way, a galaxy teeming with stars, planets, and countless other solar systems, each with its own unique story. The Milky Way itself is a member of the Local Group, a collection of galaxies bound together by gravity, swirling gently through the cosmos. Beyond the Local Group lies the vastness of the Virgo supercluster, our home within the larger structure of the universe. This intricate web of galaxies forms a tapestry of cosmic wonders, each thread woven together by the fundamental forces of nature. As we journey through these vast expanses, we encounter the cosmic voids, regions of space where galaxies are scarce and dark matter is the predominant form. These voids, like the spaces between the threads of a cosmic web, add to the structure of the universe. The interplay of gravity and dark energy shapes these voids, influencing the formation and evolution of galaxies within the universe. Dark energy, the mysterious force driving the accelerated expansion of the universe, permeates all of space and affects the motion of galaxies over cosmic time scales. The nature of dark energy remains one of the greatest mysteries in modern astrophysics, challenging our understanding of the cosmos and our place within it. Turning our gaze inward, we find that the solar system structure is itself a microcosm of the universe's grand design. The planets, moons, asteroids, and comets all dance to the cosmic rhythms dictated by gravity and inertia. The sun, a medium-sized star, provides the energy that sustains life on Earth and drives the climate and weather patterns of other planets. The intricate balance of forces within the solar system ensures the stability of planetary orbits, allowing life to flourish on our home planet. It is a delicate equilibrium, one that has persisted for billions of years and will continue to do so for billions more. In this dance of celestial bodies, the Earth holds a special place, a planet rich in diversity and life, uniquely positioned within the habitable zone where liquid water can exist. This zone, sometimes referred to as the Goldilocks zone, is not too hot and not too cold, allowing for conditions that are just right for life as we know it. Our planet's atmosphere, magnetic field, and geological activity further contribute to its habitability, shielding us from cosmic rays and providing the nutrients necessary for life to thrive. As we ponder the vastness of space, we are reminded of the fragility and preciousness of our home, a solitary blue dot suspended in the cosmic ocean. The exploration of our solar system and beyond is a testament to human curiosity and ingenuity. From the early days of stargazing to the sophisticated telescopes and spacecraft of today, our quest to understand the universe has driven technological advancements and deepened our knowledge of the cosmos. Each mission, whether it be a probe to a distant planet or a telescope peering into the depths of space, expands the horizons of human experience and challenges us to think beyond the confines of our world. The data collected by these missions not only enrich our understanding of the universe, but also inspire future generations to look up and wonder at the night sky. As we reflect on these vast and intricate systems, we are reminded of the interconnectedness of all things. The particles that make up our bodies were forged in the hearts of ancient stars, scattered across the cosmos by supernovae, and eventually coalesced to form the Earth and everything upon it. This cosmic recycling underscores the unity of matter and energy, binding us to the universe in a profound and intimate way. In contemplating the universe, we gain perspective on our place within it, understanding that we are both infinitesimal and integral to the grand tapestry of existence. The search for life beyond our solar system is a natural extension of our desire to understand our own origins. The discovery of exoplanets, planets orbiting stars beyond our sun, has opened new possibilities for finding worlds similar to our own. With each new exoplanet discovered, we learn more about the diversity of planetary systems and the potential for life elsewhere in the universe. The study of these distant worlds, some within their star's habitable zone, challenges us to redefine our understanding of what it means to be a habitable planet. The ongoing search for biosignatures, signs of life on other worlds, continues to captivate scientists and laypeople alike, driving the development of more advanced telescopes and missions. In this quest to find our cosmic companions, we also turn our attention to the moons within our own solar system. Some of these moons, like Europa and Enceladus, harbor subsurface oceans beneath their icy crusts, raising the tantalizing possibility of life within our own celestial neighborhood. These hidden oceans, warmed by tidal forces and geothermal energy, may provide the necessary conditions for life to thrive, even in the absence of sunlight. Missions to these distant worlds aim to probe their icy surfaces and explore the potential for life in these alien seas. As we continue to explore the universe, we are guided by the light of distant stars, each a beacon of knowledge and wonder. The photons that journey across vast distances to reach our eyes carry with them stories of the cosmos, tales of stellar birth and death, of galaxies colliding and merging, of the universe's ever-changing landscape. These cosmic narratives unfold across time and space, reminding us of the beauty and complexity of the universe we inhabit. In our exploration of the cosmos, we also encounter the limits of human perception and understanding. The universe, with its infinite possibilities and mysteries, challenges us to expand our minds and embrace the unknown. It is a reminder that our understanding of the universe is ever-evolving, shaped by new discoveries and insights. While we have come far in our quest to comprehend the cosmos, there is still much to learn, and the journey of discovery is as infinite as the universe itself. As we draw this gentle contemplation to a close, we find solace in the knowledge that we are part of something much larger than ourselves. The universe, vast and timeless, stretches beyond our imagination, inviting us to explore its mysteries and marvel at its wonders. In this cosmic odyssey, we are not alone, for we are connected to the stars, to the planets, and to each other in the grand symphony of existence. As we journey further into the vast expanse beyond the familiar embrace of our solar system, we find ourselves contemplating the cosmic boundaries that define and encapsulate our stellar neighborhood. The solar system, a dynamic and ever-evolving entity, is not isolated, but rather part of a grander dance within the galaxy and beyond. It's intriguing to consider how even as we define the edges of our solar realm, these boundaries are not fixed in the way a wall or a fence might be, but are instead fluid, influenced by the gravitational pull of our sun, as well as by the forces and energies emanating from beyond. Beyond the outer edges of the heliopause, where the solar wind loses its dominance over interstellar space, lies the interstellar medium. This vast, almost ethereal space is composed of gas, dust, and cosmic rays, remnants of ancient stars, and the raw materials for new ones. It is a region of delicate balance, where the remnants of supernovae and the gentle pressure of starlight shape the environment. The interstellar medium is not a void, but a tapestry woven with the delicate threads of matter and energy, a cradle for the birth and death of stars. As you consider this, imagine the interstellar winds that gently buffet the boundaries of our solar system, sometimes pushing, sometimes yielding, in a slow waltz with the solar wind. The vast Oort Cloud, a theoretical repository of icy bodies, is the farthest frontier of our solar system's gravitational influence. Yet, even here, the sun's gravitational grip is tenuous, a whisper of control over these distant wanderers. The Oort Cloud is a relic from the solar system's formation, a time capsule from our star's nursery. These icy bodies, should they be nudged from their orbits, can embark on long journeys toward the inner solar system, becoming the comets that streak across our skies, their glowing tails a testament to the distant edges of our cosmic home. As we expand our view, we begin to appreciate the Milky Way galaxy as a vast and complex structure, a spiral of stars, dust, and dark matter, rotating gracefully in the cosmos. Our solar system, nestled in one of the galaxy's spiral arms, is part of a larger community of stars, each with its own planets and potential for life. It's a humbling thought, this notion that our solar neighborhood is but one of billions in the Milky Way, each orbiting the center of the galaxy over timescales that stretch our understanding of time itself. As we drift through this galactic neighborhood, we encounter the influence of dark matter, an invisible substance that neither emits nor absorbs light, yet exerts a gravitational pull. This mysterious form of matter is thought to make up a significant portion of the galaxy's mass, affecting the motion of stars and the formation of galaxies. Though we cannot see dark matter, its presence is felt, an unseen scaffolding that shapes the universe. In contemplating dark matter, we find ourselves at the threshold of the known and the unknown, a reminder of the vastness of our ignorance and the potential for discovery that lies ahead. Further still, we find ourselves contemplating the universe's largest structures, the cosmic web that stretches across the cosmos like a vast, interconnected network. This cosmic web is composed of galaxy clusters and superclusters, interconnected by filaments of dark matter and intergalactic gas, with vast voids between them. The Virgo supercluster, which houses our Milky Way, is but one node in this immense structure, a testament to the scale and complexity of the universe. As we ponder this cosmic web, we are reminded of the interconnectedness of all things, from the smallest particles to the grandest structures. The cosmic web is not static, but rather in constant motion, expanding with the universe itself. This expansion is driven by dark energy, a mysterious force that permeates all of space, pushing galaxies apart at an accelerating pace. Dark energy's nature is one of the greatest unsolved mysteries of modern cosmology, a puzzle that challenges our understanding of the fundamental forces of nature. As we consider this expansion, we are reminded of the universe's dynamic nature, a vast, unfolding story that we are privileged to witness and explore. Amongst these grand structures, our solar system is a microcosm, a small yet intricate part of the universe's vast tapestry. The forces that govern the cosmos are at play here, from gravity to electromagnetism, shaping the planets, moons, and other celestial bodies that orbit our sun. Each planet, each moon, is a world unto itself, with its own history and potential for life. As we explore these worlds, we gain insight into the processes that have shaped our own planet and the possibilities that lie beyond. In contemplating the solar system's boundaries, we also reflect on our place within it. Earth, our home, is a rare and precious world, uniquely suited to support life. It is within the habitable zone, or Goldilocks zone, a region where conditions are just right for liquid water to exist. This delicate balance is a reminder of the fragility and resilience of life, a testament to the complex interplay of forces that sustain us. As we look to the stars, we are reminded of our shared origins, the common threads that bind us to the cosmos. Our exploration of space, both within our solar system and beyond, is an expression of our innate curiosity, a desire to understand our place in the universe. The search for exoplanets, planets orbiting other stars, has revealed a diversity of worlds, some of which may harbor life. With each discovery, we are reminded of the potential for life beyond Earth and the possibilities that lie within the vastness of space. As we continue to explore, we are guided by the knowledge that we are part of a larger universe, a cosmos filled with wonder and mystery. In this journey of exploration and discovery, we find ourselves connected to the cosmos, a part of the universe's grand tapestry. Our understanding of the solar system's boundaries is ever-evolving, shaped by new discoveries and insights. As we look to the future, we continue to seek answers to the questions that have captivated humanity for millennia. What lies beyond the horizon? What mysteries await us among the stars? In seeking these answers, we embark on a journey of discovery, guided by the light of the stars and the promise of the unknown. As you consider these questions, allow yourself to be drawn into the gentle rhythms of the cosmos, the slow dance of stars and galaxies, the interplay of forces that shape our universe. In this dance, we find a sense of connection, a reminder that we are part of something larger than ourselves. The universe, in all its vastness and complexity, is a source of wonder and inspiration, a testament to the beauty and mystery of existence. In your contemplation, take solace in the knowledge that the journey of discovery is never-ending, and that the universe holds infinite possibilities waiting to be explored. In this moment of reflection, as the stars continue their eternal dance, we find a sense of peace and wonder. The cosmos, in all its vastness, invites us to explore, to question, and to dream. In the gentle light of the stars, we find a connection to the universe, a reminder of the beauty and mystery that surrounds us. As we journey onward, let us carry with us the knowledge that we are part of this grand cosmic tapestry, a thread in the fabric of the universe, woven into the story of existence. As we continue our journey through the vast expanse of the cosmos, let us drift gently towards the edges of what we know, exploring the profound question of where our solar system truly ends. It is a question that invites us to contemplate the limits of our celestial neighborhood, a place where the familiar gives way to the unknown, and where the boundaries are as much a construct of our understanding as they are a feature of the universe itself. Our solar system, a harmonious ensemble orchestrated by the sun's gravitational embrace, extends far beyond the planets that we have come to know. Yet, as we traverse these outer realms, we find that the boundaries of our solar system are not rigid lines, but rather transitional zones where the influence of our star slowly wanes and the interstellar medium begins to assert its presence. Beyond the known planets lies the Kuiper Belt, a region teeming with icy bodies and dwarf planets, such as the enigmatic Pluto. It is here that the solar winds, the streams of charged particles flowing outward from the sun, begin to diminish, and the heliosphere, a vast bubble inflated by these solar winds, starts to thin. The edges of the heliosphere, known as the heliopause, mark the point where the solar wind's strength is countered by the pressure of the interstellar medium. This boundary, though invisible to the naked eye, serves as a tangible marker where the solar system's influence gives way to the broader galactic environment. It is a place of transition, where the solar wind slows and becomes turbulent, mingling with the cosmic rays that permeate the galaxy. As we ponder the boundaries of our solar system, we are drawn to the notion of the Oort Cloud, a theoretical shell of icy bodies that envelops the solar system like a distant halo. This region, though yet to be observed directly, is thought to be the source of long-period comets that occasionally grace the inner reaches of our solar system with their luminous tails. The Oort cloud, if it exists as scientists propose, represents the outermost frontier of our solar system, a realm where the sun's gravitational pull is but a faint echo of its influence at the center. It is here, at this distant threshold, that the solar system begins to merge with the interstellar medium, an intermingling of environments that blurs the lines of cosmic jurisdiction. Beyond the Oort cloud, the interstellar medium stretches out, an immense expanse filled with the building blocks of stars and planets. This space, though seemingly empty, is a tapestry woven with the remnants of ancient stars and the raw materials for new ones. It is a place where cosmic rays traverse vast distances, where gas and dust condense under gravity to form new stellar systems, and where the cycle of creation and destruction continues unabated. As we venture further into this interstellar realm, we are reminded that our solar system, with all its complexity and beauty, is but one small part of a much grander cosmic narrative. The boundaries of our solar system, therefore, are not defined solely by physical markers, but also by the interactions and influences that extend beyond the visible horizon. The gravitational reach of the sun, though diminished at great distances, continues to play a role in shaping the orbits of the outermost objects, binding them to our solar family even as they drift towards the interstellar space. Similarly, the solar system's motion through the galaxy, as it orbits the Milky Way's center, affects the interplay between our local environment and the galactic forces that shape our region of space. As we contemplate these vast distances and the delicate balance of forces at play, we are reminded of the interconnectedness of all things in the universe. The solar system, while a distinct entity, is part of a larger cosmic web, a network of stars, planets, and galaxies bound together by gravity and the shared history of the cosmos. This interconnectedness invites us to consider not only the physical boundaries of our solar system, but also the philosophical implications of our place within the universe. It challenges us to think about the nature of boundaries themselves, and how they are defined not just by physical space, but by the relationships and interactions that occur across them. In this sense, the question of where the solar system ends is as much about understanding the limits of our perception as it is about defining a physical boundary. It encourages us to look beyond the horizon of what we know, to explore the mysteries that lie just beyond the reach of our current technology and understanding. As we develop new tools and methods for exploring the cosmos, we will continue to refine our understanding of where the solar system ends and what lies beyond. Yet, even as we push the boundaries of exploration, there is a certain peace in acknowledging that some mysteries may remain just out of reach. The universe, in its vastness and complexity, offers a humbling reminder of the limits of human knowledge. It is a gentle invitation to embrace curiosity and wonder, to take comfort in the journey of discovery itself, and to appreciate the beauty of the cosmos in all its unfathomable scale. As we reflect on these ideas, let us also take a moment to consider the future of exploration. The quest to understand the boundaries of our solar system is part of a broader endeavor to explore the universe, a journey that will take us to the farthest reaches of space and time. It is a journey that requires not only advanced technology and scientific acumen, but also a profound sense of curiosity and wonder. In the coming years and decades, as we send probes to the outer planets, study the distant edges of the heliosphere, and perhaps one day explore the Oort Cloud, we will continue to expand our understanding of the solar system's boundaries and our place within the cosmos. This journey, though challenging, is a testament to the enduring spirit of exploration that defines humanity's quest for knowledge. It is a journey that transcends the boundaries of time and space, connecting us to the explorers of the past who gazed at the stars and wondered about their place in the universe. As we look to the future, we do so with a sense of continuity, building on the discoveries of those who came before us and paving the way for future generations to explore the mysteries of the cosmos. As we bring our gentle exploration of the solar system's boundaries to a close, let us carry with us a sense of peace and wonder. The universe, with all its mysteries and marvels, is a source of endless fascination, a reminder of the beauty and complexity that lies beyond our everyday experience. In this quiet contemplation, we find a space for reflection, a moment to appreciate the vastness of the cosmos and our small place within it. And so, with a heart full of wonder and a mind open to the possibilities of the universe, we pause here in our journey. The cosmos awaits, a realm of infinite discovery and boundless beauty, inviting us to explore its depths and to ponder the mysteries that lie beyond the horizon. As we drift further into the depths of this cosmic journey, our imaginations gently sail beyond the familiar boundaries of our solar system, venturing into the vast and enigmatic expanse that stretches infinitely before us. The concept of where the solar system ends is not merely about distance or the fading light of our sun. Rather, it is a delicate dance between the forces that govern our universe, a harmonious interplay of gravity, energy, and matter that defines the structure of the cosmos. Beyond the heliopause, where solar winds give way to the interstellar medium, lies a region that whispers the secrets of the galaxy, a place where stardust and cosmic rays mingle in an endless ballet of creation and destruction. This is a realm that defies simple definitions, where the edges of our solar system blend seamlessly into the broader tapestry of the Milky Way. As we ponder these distant frontiers, we encounter the notion of the interstellar medium itself, a vast, diffuse collection of gas, dust, and cosmic rays that fills the space between stars. It is a gentle breath of the galaxy, a reminder of the cycles of birth and death that have shaped the universe since time immemorial. The interstellar medium is not empty, but rather a canvas painted with the remnants of ancient stars, the building blocks of future solar systems. Here, in this serene expanse, atoms and molecules drift through the void, occasionally coalescing to form new stars and planets. It is a slow, deliberate process, one that unfolds over millions of years, yet it is the very essence of cosmic creation. As you contemplate this, imagine the subtle, almost imperceptible movements of these particles, drawn together by the gentle pull of gravity, slowly giving rise to the wonders we observe in the night sky. Beyond the interstellar medium lies the galactic halo, an ethereal region that envelops the Milky Way in a gentle embrace. This halo is composed of dark matter, a mysterious and invisible substance that interacts with the universe not through light but through gravity. While dark matter remains elusive, its presence is inferred through its gravitational effects on visible matter, influencing the rotation of galaxies and the formation of cosmic structures. It is a silent force, one that shapes the universe in profound ways, yet it remains hidden from direct observation. In considering the galactic halo, we are reminded of the many mysteries that still elude our understanding, inviting us to approach the cosmos with humility and an open mind. As we continue our exploration, we find ourselves contemplating the broader structure of the universe itself. Our solar system, nestled within the Orion arm of the Milky Way, is but a tiny part of a vast cosmic web, a latticework of galaxies stretching across the universe. This cosmic web is a testament to the interconnectedness of all things, where galaxies are bound together by the gravitational threads of dark matter, forming a network that spans the cosmos. Imagine, if you will, the delicate strands of a spider's web, each filament vibrating in response to the movements of the others, a symphony of unseen forces that binds the universe together. Within this grand tapestry, the Milky Way is but one of billions of galaxies, each a collection of stars, planets, and cosmic phenomena, each with its own story to tell. Some galaxies are spirals like our own, with elegant arms that spiral gracefully around a central bulge. Others are elliptical, vast collections of stars that form smooth, featureless shapes. Still, others are irregular, their chaotic forms a testament to the turbulent forces that have shaped them over time. Each galaxy, regardless of its form, is a beacon of light in the darkness, a reminder of the myriad possibilities that exist within the universe. As we gaze deeper into the cosmos, we encounter the cosmic microwave background radiation, a faint glow that permeates the universe, a relic from the time shortly after the Big Bang. This radiation is a snapshot of the infant universe, a time when it was hot, dense, and filled with a primordial soup of particles. Over billions of years, the universe has expanded and cooled, and the cosmic microwave background radiation has stretched into the microwave region of the electromagnetic spectrum. It is a gentle whisper from the past, a reminder of the universe's origins and the processes that have led to the formation of stars, galaxies, and, ultimately, life itself. Contemplating these vast scales and ancient histories, one cannot help but feel a sense of connection to the cosmos. We are made of star stuff, the elements that compose our bodies forged in the nuclear furnaces of stars long gone. As we explore the universe, we are, in a sense, exploring our own origins, seeking to understand the processes that have given rise to the complexity and diversity of life. The quest to understand the universe is, at its heart, a quest to understand ourselves, to find our place in the cosmos, and to appreciate the intricate, interwoven tapestry of existence. In this gentle meditation on the cosmos, we find solace in the knowledge that we are part of something much larger than ourselves, a universe bound together by the fundamental forces of nature and the delicate balance of matter and energy. The boundaries of the solar system, though seemingly distant and abstract, are merely a starting point for a journey that extends into the farthest reaches of the universe. It is a journey that invites us to look beyond the horizon, to embrace the unknown with curiosity and wonder, and to reflect on the profound interconnectedness of all things. As we bring this exploration to a close, let us linger for a moment in the stillness of the cosmos, taking comfort in the knowledge that the universe is a place of beauty and mystery, a vast expanse that invites us to dream and to inquire. In this quiet reflection, we find peace and a sense of belonging, knowing that we are part of a cosmic story that continues to unfold, a story that is as much about discovery as it is about the simple act of being. Here, in the gentle embrace of the universe, we find ourselves at home, ready to continue our journey into the unknown, guided by the light of the stars and the whisper of the cosmic winds. As we continue to explore the vast reaches of our cosmic neighborhood, we find ourselves pondering the question, where does our solar system truly end? The boundaries of our solar system are not marked by a clear line or barrier, but rather, they are defined by a series of gradually fading influences and forces. Our journey takes us beyond the familiar planets and their moons, past the frozen realms of the Kuiper Belt, where icy remnants of the early solar system linger in a dark, cold embrace. Here, beyond the orbit of Neptune, lies a region filled with countless small bodies, including the dwarf planet Pluto, each orbiting silently in the distant reaches of our solar system. Yet even beyond this region lies another boundary, known as the heliopause, where the solar wind, a stream of charged particles emanating from the sun, finally yields to the vastness of interstellar space. This delicate boundary is not a physical barrier, but rather a region where the influence of our sun's solar wind diminishes, and the particles of the interstellar medium begin to assert their presence. As we drift past this point, we enter the realm of the Oort Cloud, a theoretical shell of icy bodies that encircles our solar system. The Oort Cloud is thought to be the source of many comets that occasionally visit the inner solar system, their icy tails glowing in the reflected sunlight as they make their long journeys from the outermost regions of our cosmic neighborhood. Beyond the Oort Cloud, we find ourselves in true interstellar space, where the gravitational pull of the sun weakens and the influence of nearby stars begins to become more pronounced. Here, space is not empty, but rather filled with a tenuous mix of gas and dust, the building blocks of new stars and planets. It is a region where the forces of gravity and time work together to shape the future of galaxies, as clouds of gas and dust slowly coalesce under their own gravity, giving birth to new stellar systems in a process that has been repeating for billions of years. The concept of where our solar system ends is intrinsically linked to our understanding of the sun's influence, both in terms of gravity and the solar wind. As we venture farther into the cosmos, the gravitational pull of our sun diminishes, and the interstellar medium becomes more significant. This transition is a gradual one, with no abrupt boundary, but rather a fading of one influence and the rising of another. It is a reminder of the interconnectedness of all things in the universe, where boundaries are often defined not by physical barriers, but by the interplay of forces and energies that shape the cosmos. As we contemplate these distant regions, we are reminded of the Voyager spacecraft, humanity's farthest travelers, which continue their journey through the heliosphere and into interstellar space. These silent emissaries carry with them the sounds and images of Earth, a message to any who might encounter them in the vast expanse of the universe. Their journey is a testament to human curiosity and the desire to explore and understand the cosmos, a reflection of our innate drive to reach beyond the boundaries of our own world and seek out the mysteries of the universe. The concept of where our solar system ends is not only a question of distance, but also of influence. It invites us to consider the nature of boundaries themselves, how they are defined not only by space, but also by the forces that shape and permeate it. The heliopause, the Oort cloud, and the interstellar medium are all parts of a continuum, a seamless transition from one realm to another, each with its own unique characteristics and mysteries to explore. The journey to understand the end of our solar system is also a journey to understand the beginning of new worlds. For the material that fills interstellar space, the gas and dust that drift between the stars, is the very substance from which new solar systems are born. In this way, the end of one system is the beginning of countless others, each with its own potential for life and discovery. It is a cycle of creation and transformation that has been ongoing since the dawn of time, a process that continues to shape the universe around us. As we drift further into the cosmos, let us take a moment to reflect on the journey we have undertaken, not only through space but through time. For the universe is not static but constantly evolving, a dynamic tapestry of forces and energies that shift and change over the millennia. It is a reminder of the ephemeral nature of all things, the fleeting moments of existence that make up the vast continuum of time. In this exploration, we find a sense of connection, not only to the universe but to each other. For the same stars that guide our journey across the cosmos have also guided countless other travelers, both human and otherwise, throughout history. They serve as beacons in the night, reminders of the shared experience of all who have looked up at the sky with wonder and curiosity. The journey to the edge of our solar system and beyond invites us to look at the universe with new eyes, to see the familiar in a new light, and to find beauty in the unknown. It is a journey that does not end, for even as we reach the boundaries of our solar system, we are reminded of the infinite possibilities that lie beyond. As we continue our exploration, let us carry with us a sense of wonder and curiosity, for the universe is vast, and its mysteries are many. In this vastness, we find not only the answers to our questions but also new questions to ponder, each leading us further along the path of discovery. It is a journey that we undertake together, as fellow travelers in a universe that is as mysterious as it is beautiful. As we conclude our reflection on the boundaries of our solar system, let us take a moment to appreciate the journey itself, the exploration of ideas and the wonder of the cosmos. For in this journey, we find a sense of peace and connection, a reminder of the beauty of the universe and our place within it. It is a journey that continues as we look to the stars and beyond with curiosity and wonder. As we drift further into the vastness of cosmic space, we find ourselves contemplating the delicate balance that exists at the edges of our solar system and beyond. This realm is not just a boundary, but a frontier that marks the gradual blending of our solar system's influence with the wider tapestry of the Milky Way galaxy. Here, the particles of the solar wind slow to a crawl, and the sun's magnetic field extends thinly, like a gentle whisper meeting the cool, quiet expanse of interstellar medium. This boundary, the heliosphere, is shaped much like a comet, with its tail stretching far into the galaxy, a result of the ever-present motion of our solar system as it orbits the galactic center. Imagine for a moment the journey of a particle, born in the fiery heart of the sun, carried outward by the solar wind. It travels past planets, through the asteroid belt, and into the cold, distant regions beyond Neptune. Eventually, it reaches the heliopause, that elusive border where the sun's influence wavers and interstellar winds hold sway. Here, it joins an endless dance with particles from other stars, each carrying the signatures of their origins, whispering stories of their own distant suns. The boundary of our solar system is also defined by the gravitational reach of the sun, which extends far beyond the visible planets. This gravitational influence gently tugs on countless icy bodies in the Oort Cloud, a vast, spherical shell enveloping the solar system. Though it remains a theoretical construct, the Oort Cloud is thought to be a source of long-period comets that occasionally grace our skies. These comets, with their luminous tails, are messengers from the edge, bearing ancient material from the dawn of the solar system, untouched for billions of years. In this way, they offer a rare glimpse into our cosmic past, connecting us to the primordial processes that shaped our celestial neighborhood. As we consider the broader Milky Way, our solar system is but one of billions of similar systems, each with its own unique arrangement of planets, moons, and asteroids. The galaxy itself is a vast spiral structure, with its arms stretching out like the limbs of a cosmic pinwheel, home to stars in various stages of life. Our solar system resides in the Orion Arm, a minor spiral arm of the Milky Way, nestled between two larger arms filled with stellar nurseries and ancient star clusters. The stars around us, each with their own planets, create a rich tapestry of potential, hinting at the diversity and abundance of life in the universe. Beyond the Milky Way, the universe is a network of galaxies, each a swirling collection of stars, dust, and gas bound together by gravity. These galaxies are part of larger structures known as galaxy clusters and superclusters, woven together by the vast cosmic web. This web is composed of filaments of dark matter, an elusive form of matter that does not emit or interact with electromagnetic radiation, making it invisible to the eye. Yet its gravitational effects are profound, guiding the formation and evolution of galaxies and the universe itself. As we journey through these immense scales, we come to appreciate the delicate interplay of forces that govern the cosmos. The fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, work together to shape the universe from the smallest particles to the largest galactic structures. Gravity, the force that binds our feet to the Earth, also holds galaxies together and drives the expansion of the universe. It is the architect of orbits, the sculptor of stars, and the silent hand that guides the dance of celestial bodies through the cosmos. Within this cosmic framework, the universe is ever-changing, a dynamic system where matter and energy constantly interact and transform. Stars are born in nebulae, live their lives fusing elements in their cores, and eventually die, sometimes in spectacular supernovae, dispersing heavy elements into space. These elements, forged in the hearts of stars, become the building blocks for new stars, planets, and even life itself. This cycle of birth, death, and rebirth is a fundamental aspect of the universe, connecting all things through space and time. Our understanding of the universe is continually evolving as well, driven by our innate curiosity and desire to comprehend the cosmos. Telescopes on Earth and in space peer deeper into the universe than ever before, capturing light from the earliest galaxies and providing insights into the universe's origins. Instruments like the Hubble Space Telescope have revolutionized our view of the cosmos, revealing the beauty and complexity of distant galaxies, nebulae, and star clusters. Meanwhile, missions like the James Webb Space Telescope promise to further unravel the mysteries of the universe, allowing us to study planets around other stars and search for signs of life. As we look outward, we also turn our gaze inward, towards our own planet and the life it harbors. Earth is a rare and precious oasis in the vastness of space, teeming with life and diversity. The processes that sustain life here are intimately connected to the cosmos, from the sun's energy that drives our climate and weather, to the elements that form our bodies, forged in the cores of ancient stars. Understanding our place in the universe helps us appreciate the fragility and wonder of life on Earth, encouraging us to cherish and protect our planet for future generations. In this journey through the cosmos, we are reminded of the interconnectedness of all things, from the smallest particles to the grandest galaxies. We are part of a universe that is vast, beautiful, and full of mystery, a universe that invites us to explore and discover. Our quest for knowledge is a shared human experience, one that transcends borders and unites us in a common pursuit. As we continue to explore the universe, we do so with a sense of wonder and humility, recognizing that we are a small but significant part of a much larger whole. The end of the solar system is not a boundary but a beginning, an invitation to look beyond and seek understanding in the unknown. It is a reminder that our journey is an ongoing one, filled with discoveries yet to be made and questions yet to be answered. As we venture forth, we carry with us the stories of our past and the dreams of our future, guided by the light of the stars and the promise of what lies beyond. As we stand at the threshold of cosmic exploration, contemplating where the solar system truly ends, we find ourselves immersed in the gentle interplay of celestial boundaries. The concept of boundaries in space is often more abstract than tangible, shaped not by visible markers, but by the gradual fatting of one influence into another. Beyond the familiar planets and their orbits, the solar system extends much further than our immediate neighborhood, reaching into regions less frequently traversed, where the sun's influence begins to yield to the broader galaxy. In our quest to define the solar system's edge, we turn our attention to the heliopause, the boundary where the solar wind, a stream of charged particles emanating from the sun, slows down and is eventually overtaken by the interstellar medium. This region is not a definitive line, but rather a transition zone, a place where the solar wind and the interstellar material engage in a delicate dance. The heliopause represents the outermost layer of the heliosphere and serves as a protective bubble that shields our solar system from a significant portion of galactic cosmic rays. The Voyager spacecraft, sent on their remarkable journey decades ago, have ventured into these distant realms, providing us with invaluable data. Voyager 1, in particular, crossed this boundary in 2012, entering interstellar space, and Voyager 2 followed in 2018, offering a second perspective on this mysterious frontier. Beyond the heliopause lies the vast expanse of interstellar space, a region that is still part of our galaxy, but marks the beginning of the sun's waning influence. Here, the solar system's boundary is redefined not by the absence of something, but by the presence of an interstellar environment that holds its own mysteries and wonders. In this domain, the solar system's components are intermingled with cosmic elements that have traversed the galaxy for eons, whispering stories of distant origins and cosmic evolution. While the heliopause signifies one boundary, the concept of the solar system's end can also be contemplated through the lens of gravitational influence. The solar system is not merely defined by its immediate objects, but by the sun's gravitational pull, which extends far beyond the planets, reaching into the depths of the Oort Cloud. This distant region, yet to be directly observed, is thought to be a vast shell of icy bodies encircling the solar system, remnants from its formation, and a reservoir for comets that occasionally grace our skies with their ethereal displays. The Oort Cloud stretches nearly a light-year from the Sun, a testament to the Sun's enduring gravitational embrace. As we delve deeper into this outer realm, we are reminded of the significance of gravitational boundaries. The sphere of the Sun's gravitational influence, known as the Hill sphere, is another way to envision the solar system's reach. Within this sphere, the Sun's gravitational force is dominant compared to the gravitational pulls of other stars. This range is vast but finite, suggesting that even at these great distances, the Sun maintains its role as the central anchor of our solar system. In contemplating these boundaries, we find ourselves connected to the larger narrative of the galaxy. Our solar system is but one of countless others, each with its own structure and limits, each contributing to the grand tapestry of the Milky Way. The galaxy itself is a dynamic entity, with its spiral arms, rotating disk, and halo of stars and dark matter, all bound together by gravity. As we explore the outskirts of our own solar system, we gain insights into the processes that shape not only our local environment, but also the broader galactic context in which we reside. In this gentle exploration of the solar system's edge, we are drawn into the quiet contemplation of cosmic distances. The vastness of space invites us to reflect on the interconnectedness of all celestial bodies, how they are held together by the fundamental forces and the subtle interplay of energies and particles. As we journey outward, we are reminded that our understanding of the universe is both a pursuit of knowledge and a connection to something greater than ourselves, a reminder of our place in the cosmos and the infinite possibilities that lie beyond. In this serene narrative, we find comfort in the constancy of the natural laws that govern our universe, the same laws that allow us to predict the paths of comets and understand the life cycles of stars. Each new discovery, whether it be from spacecraft venturing into unknown territories or telescopes peering into the depths of space, adds to our collective understanding and appreciation of the universe's complexity and beauty. As we draw this exploration to a close, we find ourselves gently returning to our own place within this cosmic expanse. Our solar system, with its myriad wonders and mysteries, serves as a microcosm of the universe at large, a place where we can continue to explore, learn, and wonder. In this tranquil moment, we are reminded of the continuity of discovery, the ongoing journey that invites us to look beyond the stars and into the vastness that awaits. The universe is vast, yet it is also intimately connected, and in this connection we find a sense of belonging and an invitation to explore further, ever curious about the mysteries that lie beyond the horizon. As we continue our serene journey through the vastness of cosmic space, let us gently drift beyond the confines of our familiar solar system, further into the expansive realms that await us. The notion of the solar system's end is, indeed, a fluid concept, shaped by the intricate dance of celestial forces and the delicate interplay of gravitational fields. As we ponder these celestial boundaries, we find ourselves at the edge of the heliosphere, pondering the faint whisper of solar wind that has traveled millions of miles from the sun's surface. This wind, a stream of charged particles, paints a bubble around our solar system, a gentle reminder of the sun's enduring influence, even at such great distances. Yet, as we move outward, the interstellar medium begins to assert its presence, a subtle transition that brings us into the domain of the interstellar winds flowing from distant stars. Beyond the heliosphere lies the enigmatic Oort Cloud, an ethereal sphere of icy bodies that envelops our solar system. This distant region, theorized rather than directly observed, stands as a testament to the Sun's gravitational reach, extending far beyond the planets we know. Here, comets reside in a dormant state, awaiting a gravitational nudge that might send them sunward, gracing our skies with their ephemeral beauty. It is within this vast cloud that the boundaries of our solar system blur, blending seamlessly into the surrounding galactic environment. The Oort Cloud serves as a cosmic archive, preserving remnants from the Sun's formation over 4.5 billion years ago, whispering stories of ancient collisions and the early solar nebula from which our planetary family emerged. As we drift further, we encounter the realm of interstellar space, a place where the influence of our Sun fades into the background hum of the galaxy. Here, we find ourselves among the stars, each a distant solar system in its own right, bound by the gravity of the Milky Way. The space between these stars is not empty but filled with a tenuous mixture of gas and dust, the building blocks of future stars and planets. This interstellar medium cradles the galaxy, acting as a cosmic tapestry upon which the drama of stellar evolution unfolds. It is here, amidst these gentle clouds of hydrogen and helium, that the seeds of new solar systems are planted, destined to one day ignite into the brilliant glow of newborn stars. Our exploration of these cosmic boundaries invites contemplation of the forces that govern such vast distances. Gravity, that fundamental force that binds the universe together, extends its reach far beyond the planets, holding the Oort Cloud in its gentle embrace. Meanwhile, the faint pressure of light and the solar wind push outward, sculpting the heliosphere's shape as it travels through the galaxy. These forces, though seemingly insubstantial, shape the very structure of our solar neighborhood, weaving a complex web of interactions that guide the motion of celestial bodies. As we drift through this cosmic expanse, we are reminded of our place within the grand tapestry of the Milky Way. Each solar system, enveloped in its own heliosphere, contributes to the galaxy's intricate structure, much like the cells that compose a living organism. Our solar system, though but a single thread in this vast cosmic fabric, is connected to a larger narrative, one that spans the breadth of the galaxy and beyond. The stars that dot our night sky, each twinkling point of light, are distant suns, each with their own planets, perhaps even harboring life. This journey through the outer reaches of our solar system fosters a sense of connectedness, a realization that we are part of something much larger than ourselves. The boundaries we explore are not merely lines of demarcation, but pathways that connect us to the larger universe. In understanding where our solar system ends, we also come to appreciate the beginning of the interstellar journey, one that leads us to new discoveries and deeper insights into the nature of the cosmos. Let us take a moment to reflect on the profound beauty of this interconnected universe, where the dance of celestial bodies unfolds in a harmonious symphony. The heliosphere, the Oort Cloud, and the interstellar medium each play their part in this cosmic ballet, their interactions choreographed by the laws of physics that govern the universe. These laws, universal and unchanging, guide the formation of stars and planets, the birth and death of solar systems, and the evolution of galaxies over billions of years. As we continue to ponder the mysteries of the universe, we are reminded of the power of scientific exploration and the human spirit's insatiable curiosity. The boundaries of our solar system, once thought to be fixed and finite, have expanded with our understanding, revealing new realms to explore and new questions to answer. Our inquisitive nature drives us ever outward, seeking to unravel the secrets of the cosmos, to understand the forces that shape the universe, and to find our place within this vast and wondrous expanse. In contemplating these mysteries, we find solace in the knowledge that we are never truly alone in the universe. The stars that illuminate our night sky, the planets that orbit distant suns, and the galaxies that stretch across the cosmos are all part of a grand design, a cosmic story that unfolds over the eons. Each of us, in our own small way, contributes to this narrative, our actions and discoveries woven into the fabric of space and time. As we bring this gentle exploration to a close, let us carry with us the sense of wonder and connection that comes from contemplating the universe's boundless beauty. Our journey through the solar system's boundaries has led us to the very edge of human understanding, where the known meets the unknown, and where each new discovery paints a richer picture of the cosmos. In this vastness, we find a reflection of our own potential, a reminder that the universe is a place of endless possibilities, waiting to be explored with open hearts and curious minds. And so, as we drift back to our own corner of the universe, let us hold on to the knowledge that we are part of something truly magnificent. Our solar system, a tiny oasis in the great cosmic ocean, is but one of countless others, each a beacon of light in the darkness, each a testament to the power of creation and the enduring beauty of the cosmos. With each new day, we have the opportunity to explore, to learn, and to grow, ever mindful of our place in this wondrous universe, and ever grateful for the chance to be a part of its unfolding story. As we continue our gentle voyage through the vast expanse of space, we find ourselves contemplating the very nature of boundaries in the cosmos. The question of where our solar system truly ends is not merely a matter of distance or location, but rather an exploration of the intricate transitions and connections that mark the frontier between the familiar and the unknown. Beyond the heliosphere, where the solar wind gives way to the interstellar medium, lies a realm where the sun's influence begins to wane, and the forces of the galaxy at large begin to take precedence. Here, in this delicate balance between the pull of our star and the embrace of the Milky Way, we come to understand the concept of the heliopause. This is the boundary where the pressure from solar winds is countered by the interstellar medium, a region that serves as a dynamic and ever-shifting line, demarcating the edge of our solar neighborhood. As you drift through this cosmic threshold, imagine the Voyager spacecraft, those silent emissaries of human curiosity, as they journey outward, sending back whispers of data from these distant realms. Launched in the late 1970s, Voyager 1 and Voyager 2 have traversed beyond the heliosphere, becoming our eyes and ears in the vastness of interstellar space. These spacecraft, now billions of miles from home, continue to transmit invaluable information about the conditions that exist beyond our solar system's protective bubble. They have confirmed that the heliopause is not a static boundary, but rather a fluctuating zone that shifts with the solar cycle and interstellar conditions, reminding us of the dynamic nature of our cosmic environment. Beyond the heliopause lies a region known as the heliosheath, where the solar wind slows dramatically and becomes turbulent as it interacts with the interstellar medium. This area is a turbulent sea of charged particles, a place of transition where the solar wind's influence is finally absorbed and the interstellar winds begin to take hold. The heliosheath is thought to be the final frontier of the sun's dominion, a place where the outward push of solar particles is finally overcome by the gentle but persistent pressure of the interstellar winds. It is here that the solar system's narrative begins to blend with the broader story of the galaxy, as we step into a realm shaped by forces that have been at work for billions of years. Continuing outward, we enter the interstellar space proper, a vast expanse filled with a thin soup of gas and dust, the remnants of ancient stars and the raw materials for future ones. This interstellar medium is a place of both destruction and creation, where stellar winds and supernovae have scattered elements across the galaxy, seeding the clouds of gas that will one day coalesce into new stars and planets. In this way, the universe is continually recycling itself, a cosmic dance of death and rebirth that has played out over eons. It is a humbling reminder of the interconnectedness of all things, a testament to the cycles that govern the cosmos on scales both small and large. As we ponder the vastness of interstellar space, we are drawn to the concept of the local interstellar cloud, a region of slightly denser gas within the interstellar medium that our solar system is currently passing through. This cloud, sometimes referred to as the local fluff, is a testament to the varying density and composition of the interstellar medium, a reminder that even in the emptiness of space, there is structure and form. The local interstellar cloud is thought to be a remnant of ancient supernovae, a cloud of gas and dust that has been shaped by the forces of gravity and magnetism over millions of years. As our solar system moves through this cloud, it is shielded from the harshest cosmic rays by both the heliosphere and the cloud itself, a delicate balance that has allowed life to flourish here on Earth. Far beyond the influence of the local interstellar cloud, we encounter the larger structure of the Orion arm of the Milky Way, the spiral arm of our galaxy where our solar system resides. This arm is part of a majestic spiral pattern that defines the shape of our galaxy, a swirling dance of stars and gas that has been sculpted by gravity over billions of years. The Orion arm is home to many of the stars visible in our night sky, as well as countless others that are too faint to be seen without the aid of telescopes. It is a place of birth and death, where new stars are born from the ashes of old ones, a testament to the ongoing cycle of creation that defines our universe. As we contemplate the structure of our galaxy, we are reminded of the role that dark matter plays in shaping the cosmos. While invisible and mysterious, dark matter exerts a gravitational influence that helps hold galaxies together, preventing them from flying apart as they spin. Though its true nature remains elusive, dark matter is an essential component of the universe, a silent partner in the grand dance of the cosmos. It is thought to comprise most of the mass in the universe, a hidden framework that supports the visible structures we see, from galaxies to galaxy clusters. Beyond our galaxy, the universe stretches out into an expanse that is almost beyond comprehension. The observable universe is thought to contain at least 2 trillion galaxies, each a vast collection of stars, planets, and other celestial bodies. These galaxies are not scattered randomly, but rather form a web-like structure on a cosmic scale, with clusters and filaments of galaxies separated by vast voids. This large-scale structure of the universe is a testament to the power of gravity, which has shaped the cosmos from the smallest scales to the largest. As we drift through this cosmic ocean, we find ourselves reflecting on the nature of time and distance in the universe. Light, the fastest thing in the universe, takes years to travel from even the nearest stars, and millions or billions of years to reach us from distant galaxies. When we look into the night sky, we are looking back in time, seeing stars and galaxies as they were when their light first began its journey to us. This light has traveled across unimaginable distances, bringing with it stories from the past, a window into the history of the universe. In this vast tapestry, our own solar system is but a tiny speck, a single star among hundreds of billions in the Milky Way galaxy. And yet, within this small corner of the universe, life has emerged, a complex web of biology that has evolved over billions of years. It is a reminder of the uniqueness of our planet, a testament to the delicate balance of conditions that have allowed life to thrive. As we explore the universe, we are constantly reminded of the rarity and preciousness of life, a fragile thread in the vast fabric of existence. Our journey has taken us from the familiar edges of the heliosphere to the distant reaches of interstellar space, weaving a narrative that connects our solar system to the galaxy and beyond. It is a story of boundaries and connections, of the forces that shape the cosmos and the delicate interplay of gravity and time. As we continue to explore the universe, we are guided by a sense of wonder and curiosity, ever seeking to understand the mysteries that lie beyond the horizon. And so, as we drift through the stars, we are reminded of our place in this vast and beautiful universe, a part of a story that is both ancient and ever new, a journey of discovery that continues to unfold with each passing moment. As we drift further from the familiar confines of our solar system, one can't help but ponder the nature of boundaries in space. These boundaries are not abrupt edges like the walls of a room, but are instead gradual transitions where one realm gives way to another, subtly and naturally. Beyond the heliopause, where the solar wind slows and mingles with the interstellar medium, the universe stretches into realms of profound subtlety and expansiveness. Here, the solar wind's influence finally wanes, and the particles that once danced to the rhythm of the sun find themselves in the company of atoms and molecules that have traveled from distant stars, perhaps even from the beginnings of our galaxy. In this vastness, the interstellar medium is more than just a void. It is a tapestry woven with the remnants of ancient stars, the ashes of supernovae, and the whispers of cosmic winds that have traveled across the galaxy for millennia. The particles here are sparse, yet they form a delicate bridge connecting us to the broader cosmos. As the Voyager spacecraft continue their journey through this interstellar medium, they send back messages across the vast distances, whispers from the edge of human reach, telling of a space that is cold, sparse, yet filled with the potential for discovery. As we contemplate these distant reaches, it is fascinating to consider the role of cosmic rays, those high-energy particles that zip through the galaxy at near-light speeds. Originating from supernova explosions and other energetic cosmic phenomena, these particles traverse the galaxy, reaching even the farthest corners of our solar system. The local interstellar cloud, with its slightly denser concentration of gas and dust, provides a sort of buffer, a protective cocoon that mitigates the impact of these cosmic rays. Within this cloud, we find not only a protective environment, but also a reminder of the interconnectedness of cosmic structures, each playing its part in the grand orchestration of the universe. As we move beyond these localized regions, we find ourselves contemplating the intricate structure of our galaxy, the Milky Way. This spiral galaxy, with its swirling arms and luminous core, is a marvel of cosmic architecture. The Orion Arm, our galactic neighborhood, is but one of many such arms that spiral outward from the core, each filled with stars, planets, and the potential for life. These arms are not static. They are dynamic, shaped by the gravitational forces of the stars within them and the unseen influence of dark matter, that mysterious substance that permeates the universe, influencing its structure and evolution. Dark matter, while not directly observable, exerts a gravitational pull that affects the motion of stars and galaxies. It helps to bind galaxies together, forming the cosmic web, a vast network of interconnected galaxy clusters that stretch across the universe. This web-like structure is one of the largest known formations in the cosmos, a testament to the complexity and wonder of the universe. Each thread of this cosmic web is made up of galaxies, each galaxy home to billions of stars, and around many of these stars, the potential for planets and perhaps even life. As we gaze outward, we find ourselves contemplating the vast distances that separate these cosmic structures. Light, the fastest thing in the universe, takes years to travel from one star to the next, and millions of years to traverse the distances between galaxies. These immense spans of space and time remind us of the scale of the universe and our place within it. Yet, even in this vastness, there is a sense of connection, a sense that we are part of something much larger than ourselves. The end of the solar system, then, is not a sharp line but a fatting influence, a gentle blending into the interstellar medium that connects us to the galaxy and the universe beyond. This boundary is a place of transition, where the familiar meets the unknown, where the influence of our sun gives way to the broader forces of the galaxy. It is a place where questions linger, and where the potential for discovery is as vast as the space itself. In contemplating where the solar system ends, we are reminded of the journey of exploration, the human spirit's relentless quest to understand the cosmos. Our spacecraft, like Voyager, continue to push the boundaries of human reach, venturing into the unknown, expanding our understanding of what lies beyond. Each piece of data, Each signal sent back to Earth enriches our understanding of the universe and our place within it. These explorations also remind us of the interconnectedness of all things. The particles that make up our planet and ourselves were forged in the hearts of stars, scattered across the galaxy by supernovae, and gathered into new formations by the gravity of the sun. This cosmic recycling links us to the stars, to the galaxy, and to the universe itself. It is a reminder that the boundaries we perceive are not barriers, but points of connection, places where one aspect of the universe meets another. As we ponder these cosmic connections, it is soothing to reflect on the idea that the universe is a place of both mystery and understanding. While there is much we have yet to learn, there is also a profound beauty in what we already know, a beauty that lies in the patterns and structures of the cosmos, in the dance of galaxies, and in the intricate web of forces that shape the universe. This beauty is a source of wonder, a reminder that while the universe is vast and complex, it is also a place of harmony and order. In the quiet of the night, as you contemplate the stars, consider the journey from the familiar warmth of our sun to the distant reaches of interstellar space. It is a journey that spans not only distance but also time, a journey that connects us to the past and the future, to the stars and beyond. It is a journey that invites reflection, a gentle reminder of the beauty and wonder that lie within the cosmos and within ourselves. As our narrative drifts to a gentle pause, consider the universe not as a place of isolated objects, but as a symphony of interconnected parts, each playing its role in a grand cosmic performance. Each star, each planet, each particle is part of a larger whole, a universe that is vast yet intimately connected. In this interconnectedness, we find a sense of belonging, a sense that we are part of something much larger than ourselves, something that stretches beyond the boundaries of our solar system and into the infinite expanse of the cosmos. As we drift further out into the cosmic ocean, we find ourselves pondering the question of where our solar system truly ends. It is a question that invites us to explore the boundaries of our understanding and the limits of our reach. Beyond the heliopause lies the vastness of the Oort Cloud, an ethereal sphere of icy bodies, remnants from the early formation of our solar system, stretching far beyond the familiar orbits of our planetary neighbors. This distant region, though never directly observed, is hypothesized to be the birthplace of many comets, a repository of icy relics that occasionally venture inward, gracing our skies with their luminous tails. As we let our thoughts wander through this distant realm, we sense the gradual thinning of the sun's influence, where its gravitational grasp weakens, and the pull of other stars begins to compete. The Oort Cloud, enveloping us like a gentle cosmic fog, marks the transition from the solar system to the interstellar neighborhood. It is not a sharp boundary, but rather a gradual blending of solar and stellar influences. Here, the dance of gravitational forces becomes more complex, a delicate balance between the sun's lingering pull and the distant, yet persistent tug of nearby stars. It is a place where the solar wind no longer reaches, where the particles of our sun blend seamlessly with those from the interstellar medium, creating a mingling of cosmic materials that have traveled across the galaxy. Beyond the Oort Cloud, the concept of the solar system's boundary becomes even more abstract. Some might consider the end of the solar system to be where the sun's gravitational influence finally fades into insignificance, where its light and warmth no longer define the movements of celestial bodies. Others might look to the realm where the sun's gravitational influence gives way to the collective pull of the Milky Way's spiral arms, where the stars of our galaxy become the dominant architects of cosmic motion. It is a testament to the complexity and wonder of our universe that even something as seemingly simple as defining the edge of our solar system invites so much contemplation and awe. As we contemplate these distant reaches, our thoughts naturally turn to the paths of exploration that have taken us from our home planet out into the darkness. The journey of the Voyager and Pioneer spacecraft, bold emissaries of human curiosity, marks humanity's first steps into interstellar space. These spacecraft, now traveling beyond the heliosphere, continue to send back whispers of the cosmic environment they encounter, providing precious glimpses into the nature of the space between the stars. Their journeys remind us of the enduring spirit of exploration that drives us to seek understanding in the vast unknown. These spacecraft carry with them messages from Earth, golden records of sound and image, a time capsule of human culture and diversity aimed at reaching other intelligent beings that might one day encounter them. The recordings, carefully selected to represent the rich tapestry of life on Earth, echo through the silence of space, a testament to our desire to reach out and connect with the cosmos. As these silent travelers continue their voyage, they remind us of our place in the universe, a tiny blue dot orbiting a modest star, yet filled with a boundless capacity for wonder and exploration. The exploration of our solar system's boundaries is not just a quest for physical understanding, but also a journey into the realms of philosophical contemplation. As we consider the transition from solar to galactic space, we are reminded of the interconnectedness of all things. The particles that make up the interstellar medium, the dust and gas that float between the stars, are the same materials that once formed planets, stars, and galaxies. They are the building blocks of life itself, linking us to the universe in a profound and intimate way. In this quiet reflection, we find a sense of unity with the cosmos, a feeling that transcends the boundaries of our solar system and connects us to the greater whole. The universe, in its vastness and complexity, is a reminder of the beauty and wonder that lies beyond our immediate perception. It invites us to explore and discover, to seek and to understand, drawing us ever outward into the depths of space. As we continue our journey through the cosmos, we are reminded that the boundaries of our solar system, much like the universe itself, are not fixed or static. They are constantly shifting and changing, shaped by the forces of gravity, time, and space. This dynamic nature of the universe invites us to remain open to new discoveries, to embrace the unknown with a sense of curiosity and wonder. In the end, the question of where the solar system ends is as much about the journey as it is about the destination. It is an invitation to explore the boundaries of our understanding, to reach beyond the familiar and venture into the unknown. It is a reminder that the universe, in all its vastness, is a place of endless possibility, where each new discovery opens the door to deeper mysteries and greater wonders. As we let our minds drift through these cosmic realms, we find solace in the knowledge that we are part of something much greater than ourselves. The universe, with its intricate web of stars and galaxies, is a testament to the beauty and complexity of existence. It invites us to pause and reflect, to marvel at the wonders that lie beyond our reach, and to find peace in the infinite tapestry of the cosmos. As we continue our journey through the cosmos, the question of where the solar system truly ends invites us to ponder the vast expanses that lie beyond the reach of our sun's immediate influence. The boundary of the solar system is not a definitive line, but rather a gradual transition, an intermingling of solar and interstellar realms. Beyond the heliopause, where the solar wind meets the interstellar medium, the Oort Cloud stretches like a diffuse halo, enveloping our solar neighborhood. This distant region, though largely hypothetical and unseen, represents the outermost frontier of the sun's gravitational embrace, extending far beyond the planetary orbits we are more familiar with. The Oort Cloud is thought to be a spherical shell of icy bodies, remnants from the formation of the solar system, scattered by the gravitational influences of the giant planets long ago. It is a repository of potential comets, silently drifting in the dark, cold reaches of space. Occasionally, these icy wanderers are disturbed and begin their long journey towards the inner solar system, providing us with fleeting glimpses of their icy nuclei as they approach the warmth of the sun. The existence of the Oort cloud is inferred from the behavior of long-period comets, those that appear from seemingly random directions, and take hundreds or even thousands of years to complete an orbit around the Sun. These ancient travelers remind us of the dynamic and interconnected nature of our solar system, where even the most distant objects can eventually find their way to the heart of our celestial neighborhood. As we venture further into the depths of the cosmos, we encounter the vastness of interstellar space, where the influence of individual stars begins to blend into a collective backdrop. Here, the material between the stars, known as the interstellar medium, becomes more prominent. This diffuse mixture of gas and dust, primarily composed of hydrogen and helium, is the raw material from which new stars and planets are born. Interstellar clouds, some dense and rich with organic molecules, drift through this space, occasionally collapsing under their own gravity to form new stellar systems. This cycle of birth and rebirth, of creation and destruction, is a fundamental aspect of the cosmos, a reminder of the ever-changing tapestry of the universe. In this vast expanse, our solar system is but a tiny oasis, a small island of matter and energy amidst the cosmic sea. The distances between stars are immense, measured in light years, which represent the distance light travels in 1 year, approximately 5.88 trillion miles. Such vast distances challenge our comprehension, yet they also inspire a sense of wonder and curiosity. The journey from one star to another is not merely a physical endeavor, but a voyage of understanding, a quest to unravel the mysteries of the universe and our place within it. The interstellar medium is not empty but filled with the faint glow of starlight, scattered by dust and gas, creating a diffuse background of light that permeates space. This light, along with the cosmic microwave background radiation, the afterglow of the Big Bang, bathes the universe in a gentle luminescence. The cosmic microwave background is a relic from the early universe, a snapshot of the cosmos when it was only 380,000 years old, offering us a glimpse into the infancy of the universe and the conditions that prevailed at that time. As we contemplate the end of the solar system and the beginning of interstellar space, we are reminded of the profound interconnectedness of all things. The boundary between the solar system and the rest of the galaxy is not a sharp divide, but a region of transition, where the influence of our Sun gradually fades into the broader tapestry of the Milky Way. This interconnectedness is echoed in the very fabric of the universe, where galaxies are bound together in clusters and superclusters, forming vast cosmic structures that span millions of light years. Our galaxy, the Milky Way, is just one of billions in the observable universe, each a collection of stars, planets, and other celestial objects, bound together by gravity. The Milky Way itself is a barred spiral galaxy, with a central bulge surrounded by spiral arms rich with star-forming regions. Our solar system resides in one of these spiral arms, known as the Orion Arm or the local spur, located about 26,000 light-years from the galactic center. Here, amidst the swirling gas and dust, stars are born, live out their lives, and eventually return their material to the interstellar medium, contributing to the ongoing cycle of cosmic evolution. Beyond the Milky Way, the universe stretches out in all directions, a vast expanse of galaxies, each a universe unto itself. The distances between galaxies are even more staggering than those between stars, with some galaxies separated by millions or even billions of light years. These immense distances do not isolate galaxies from one another. Rather, they are connected by the gravitational pull of dark matter, an unseen yet pervasive component of the universe that influences the motion of galaxies and the formation of large-scale cosmic structures. Dark matter, along with dark energy, comprises the majority of the universe's mass-energy content. Dark energy, a mysterious force driving the accelerated expansion of the universe, shapes the cosmos on the largest scales, influencing the fate of the universe itself. These enigmatic components remind us of how much there is yet to discover and understand about the universe, inviting us to explore the unknown and expand our horizons. As we reflect on the boundaries of the solar system and the vastness of interstellar space, we are encouraged to consider our own place within this grand cosmic panorama. The journey of exploration is not only about reaching new destinations, but also about gaining a deeper understanding of the universe and our relationship to it. This journey is a testament to the human spirit of curiosity and the desire to explore, to seek out new knowledge and insights, and to connect with the cosmos in a meaningful way. In contemplating the end of the solar system, we find ourselves at the threshold of a much larger universe, one that is filled with wonders and mysteries waiting to be discovered. The pursuit of knowledge and understanding, of seeking answers to the questions that have intrigued humanity for generations, is a journey that transcends the physical boundaries of space and time. It is a journey that invites us to look beyond the horizon, to imagine what lies beyond, and to embrace the unknown with a sense of wonder and awe. As we continue to explore the universe, both through our scientific endeavors and our imagination, we are reminded of the beauty and complexity of the cosmos. The stars, planets, and galaxies that populate the universe are part of a vast and interconnected web, a cosmic dance that has been unfolding for billions of years. This dance is a reminder of the shared history we have with the universe, a history that is written in the stars and reflected in the very atoms that make up our bodies. In this grand cosmic narrative, each of us plays a part, contributing to the ongoing story of the universe. The exploration of the cosmos is not only about discovering new worlds, but also about understanding our own world, our place in the universe, and the interconnectedness of all things. It is about finding meaning and purpose in the vastness of space, about connecting with the cosmos in a way that transcends the limitations of our physical existence. As we ponder the boundaries of the solar system and the expanses beyond, we are invited to reflect on the profound beauty and complexity of the universe. This reflection is a reminder of the endless possibilities that await us as we continue our journey of exploration and discovery. It is an invitation to embrace the wonder of the cosmos, to seek out new knowledge and insights, and to connect with the universe in a way that enriches our understanding and appreciation of the world around us. The universe is a vast and wondrous place, filled with mysteries and wonders that beckon us to explore and discover. As we stand at the edge of the solar system, gazing out into the depths of space, we are reminded of the endless possibilities that lie before us, the endless journey of exploration that awaits. This journey is not just about reaching new destinations, but about understanding and connecting with the universe in a way that is meaningful and fulfilling. In this spirit of exploration and discovery, we are encouraged to continue our journey, to seek out new knowledge and insights, and to embrace the wonder of the cosmos with an open heart and mind. As we venture into the unknown, we carry with us the spirit of curiosity and the desire to explore, to seek out new knowledge and insights, and to connect with the universe in a meaningful and fulfilling way. This journey is a testament to the human spirit, a celebration of our shared history with the cosmos, and an invitation to explore the universe with a sense of wonder and awe. As we continue our journey through the cosmos, let us drift further into the vastness beyond the boundaries of our solar system. Beyond the Oort Cloud, where the sun's gravitational influence becomes a whisper, we are fully enveloped by the interstellar medium. Here, in this expansive ocean of space, the tiny particles of gas and dust, remnants of ancient stars, float in a delicate balance. These particles, though sparse, are the building blocks of future solar systems, the seeds from which stars and planets may one day grow. This interstellar medium is not uniform, but rather a tapestry of varying densities and temperatures, shaped by the forces of gravity and stellar winds, as stars live out their cycles of birth and death. Each particle, each dust grain, carries within it the history of the universe, a silent testament to the processes that have shaped it over billions of years. As you imagine this cosmic sea, think of the Voyager spacecraft, humanity's farthest-flung emissaries, as they sail through these uncharted waters. Launched in the late 1970s, these probes have been traveling for decades, each carrying a golden record, a message to any who might find it, detailing the sights and sounds of Earth. They have crossed the heliopause, the boundary where the solar wind's influence ends, and now they continue their journey through interstellar space. These spacecraft are our eyes and ears, sending back data that helps us understand this mysterious frontier. Though their power is waning, they continue to whisper back to us across the void, providing glimpses into the unknown. In this quiet realm, the cosmic background radiation permeates all, a faint afterglow from the Big Bang that stretches across the universe. This radiation is a relic from a time when the universe was young and hot, a time before stars and galaxies had formed. It is as if the universe has a memory, and this radiation is the echo of its earliest moments, a constant presence in the darkness of space. As you contemplate this, consider the scale of the universe, where distances are measured in light years, a testament to the incredible vastness that separates celestial bodies. Yet even in this boundless expanse, there is a gentle order. Galaxies, vast assemblies of stars, gas, and dark matter, are bound together in clusters and superclusters, forming a cosmic web that stretches across the universe. These structures are shaped by the interplay of gravity and the mysterious forces of dark matter and dark energy. Dark matter, though invisible, exerts a gravitational pull that helps to hold galaxies together. Meanwhile, dark energy, a force that we are only beginning to understand, drives the accelerated expansion of the universe, causing galaxies to drift apart over time. As you ponder these cosmic forces, reflect on the delicate balance that exists within our own Milky Way galaxy. Our solar system is but one of billions, each with its own story and potential for life. The vast distances between stars create a sense of isolation, yet they also provide a canvas for the imagination, a reminder of the infinite possibilities that lie beyond our current understanding. Within this galaxy, stars are born in stellar nurseries, regions of intense activity where clouds of gas and dust collapse under gravity to ignite nuclear fusion, giving birth to new stars and solar systems. The life cycle of a star is a majestic process, one that spans millions or even billions of years. Stars like our Sun spend the majority of their lives fusing hydrogen into helium, shining brightly in the darkness of space. When their fuel is exhausted, they undergo transformations, becoming red giants or supernovae, enriching the interstellar medium with heavy elements. These elements are the foundation of planets and life, a cosmic alchemy that connects us to the stars themselves. As you let these thoughts wash over you, consider the quiet solitude of intergalactic space, the regions between galaxies where the density of matter drops even further. In these voids, the universe expands, and yet it is not empty, but filled with the faint glow of distant galaxies, each a beacon of light in the vastness. These regions are reminders of the universe's ever-changing nature, a dynamic interplay of creation and destruction that has been unfolding for eons. In the grand scheme of things, our solar system, our planet, and indeed our own lives, are but fleeting moments in the cosmic dance. And yet in this brevity there is beauty. The universe invites us to explore its wonders, to seek answers to its mysteries, and to find our place within it. As you reflect on these distant realms, allow yourself to feel a sense of connection to the cosmos, a reminder that we are, in many ways, a part of this grand universe. And so, as we gently come to a pause in our journey through the stars, let us carry with us the quiet awe of the universe's endless expanse, the intricate tapestry of cosmic phenomena, and the profound interconnectedness that binds us all. May these thoughts inspire a sense of peace and wonder as we continue to ponder the mysteries of the universe that await beyond the horizon.